Hello, my name is Sandeep Agrawal. I am the principal investigator of the project titled Future Energy in Canadian Cities and First Nations Communities. Cities and towns account for between 37 to about 50% of all global greenhouse gas emissions. Future energy systems such as solar power, geothermal, wind power, and others are vital to making communities smart and sustainable and thus reducing greenhouse gas emissions. In this research program, we explore how prepared Canadian cities and neighborhoods are in making this transition. This research program has 4 projects in it. They are municipalities and energy transition, effective neighborhood type of energy use and greenhouse gas emissions, role of community leaks in energy transition, and lastly, energy cost and homelessness in Indigenous communities. The first project is municipalities and energy transition. Canadian municipalities are working towards reducing their greenhouse gas emissions and achieving carbon neutrality. However, not all cities are equal. Prairie cities, for instance, have a higher greenhouse gas footprint than other cities in Canada. Through an analysis of municipal energy transition plans of the cities of Edmonton, Calgary, Regina, Saskatoon, and Winnipeg, we intend to inquire whether space and place-based factors like presence in an oil and gas-rich area play a role while framing municipal transition strategies. Preliminary findings suggest that current municipal strategies are largely driven by global greenhouse gas emission reduction targets, but we recommend that addressing local geographical and political realities early on will help avoid policy frustrations at a later stage. The second project is Neighborhood Energy Use and Greenhouse Gas Emissions. It's a case study from the city of Edmonton. In this study, we explore whether the neighborhood and its elements such as building topology, land use, location, and travel behavior have any impact on greenhouse gas emissions. The findings will help us plan and design a configuration of a neighborhood that emits the least amount of greenhouse gas emissions. In this study, we considered greenhouse gas emissions from multiple sources, such as buildings, streetlights, transportation, solid waste disposal, as well as carbon dioxide sequestration by urban vegetation. We focused on 4 neighborhoods types in the city of Edmonton, and they are core neighborhoods, mature neighborhoods, established neighborhoods, and developing neighborhoods. Our preliminary results show that building topology, floor area per person, and the geographic location of the neighborhood in the city result in greenhouse gas emissions. These factors together show that developing neighborhoods, that is, the ones in dark in the map at the periphery of the city, produce more greenhouse gas emissions per capita than core and mature neighborhoods, which are at the center of the city. The third project is the role of community leagues in energy transition. Community leagues are a unique community-led grassroots organizations in the city of Edmonton. Since 2016, community leagues have worked towards diffusing the idea energy transitions in their respective communities through solar panel installations and energy audits of their community halls. In this research, we examine the opportunities and barriers that exist for community leagues in being the agents of change and leading energy transitions in their respective communities. Our findings suggest that leagues are well positioned in their communities to catalyze energy transition. However, being primarily volunteer driven, they are constrained by human resources to accelerate this process. The fourth project is the energy cost and homelessness issues in the Northwest Territories. In this study, we explore the nexus between the high cost of energy in the Northwest Territories and social issues such as housing. Our result shows that the transportation cost of diesel and the lack of economies of scale are the major reasons for the high cost of energy in Canada's north. Harsh climatic conditions, absence of integrated connectivity, and the absence of connectivity with the North American power grid are some of the major challenges in reducing the cost of energy. The higher cost of energy makes housing affordability a serious challenge. At times, despite having the privately owned housing or provided by the government, non-payment of power costs could lead to Indigenous individuals or families getting evicted, resulting in their becoming homeless. The co-investigator is Dr. Iran Kaplinsky in the Faculty of Law. Several individuals have worked on the project. The main contributors are the two postdoctoral fellows, Dr. Nilakshi Joshi and Dr. Nilusha Velagadara, and the two research assistants, Abhimanyu Jamwal and Shaval Gajar. Each will present their pieces of the project in separate videos that will follow. Thank you very much.
Thank you so much for watching Future Energy Systems video. Make sure to subscribe so you don't miss any of our exciting content. Check out the links below to our website and learning page where you can find activities, learning extension, and more. You can also sign up on the website for notifications for future videos and interactive opportunities. There's so much to learn as we explore our energy future.